Hello YouTube, welcome back. We're in Lab 7, Chapter 8. Really used to be Chapter 7, Lab 7, but that's why I call it C7X1. Chapter 7, Exercise 1, but for some reason they renumbered the chapters. So it's Lab 7, Chapter 8, Exercise 1 in the lab. You'll note that the asterisked projects are of my own making. So C7X1 is not in the lab book, C7X9 is not in the lab book, C7X11 is not in the lab book. What I'm doing in C7X1 is 3 different ways of doing Rot13, the encryption algorithm. In A, we're going to talk about using strings as arrays of characters, as static arrays of characters. And then Rot13b, we'll rewrite it, we'll refactor the class to use private instance fields that are not strings, but static integer arrays. And then in 13c, we'll refactor that and show you how to use ArrayLists of Integer objects to do basically the same thing. So the testing class is going to look the same for all 3, except for which version of Rot13 we're instantiating. But the interface will be the same. I think there's going to be a Rot13a, b, or c constructor, which is just a string. And then there's going to be a getTextIn, which is an accessor, and getTextOut, which is a mutator, or maybe we'll let the constructor do all the work. And getTextOut will just return private instance field, which is the encrypted message. Yeah, that's what we're going to do. We're going to make the constructor do all the work, and textIn, textOut are accessors. All right, so here we go. So let's go to our cs50.io. Let's go into the YouTube folder, YouTube directory, I should say. We have everything through Lab 6. Let's make a directory for Lab 7. CD that. And of course, there's nothing there. Whoops, ls. Okay. All right, so let's make dir a 13. Let's see, we're going to make separate. How about a C7X1 directory? In there, we'll have all 3 classes, C7X1a, B, C, and D, and a C7X1 tester. Or I should say a Rot13 tester. Right. So it's going to be a Rot13 tester.java, Rot13a.java, Rot13b.java, Rot13c.java. Today we're going to focus on 13a. Alrighty. So there we are. So cd that. And perfect. Okay. Now let's let's open an ASCII editor. Let's start with the tester class, or the client class. Let's see, Rot13 tester. .java. We did this a while ago. I'm going to say today's date is what? The 25th of February. I think we started this in January. But okay. So 2019. 0225 is today. Whoopsie. So the file name, your name and the date. Whoops, where's my name? Mr. G. It's been a long break. It's after February break, by the way. All right, so why don't we save this much? So I'm going to copy this as the file name. I'm going to save. Well, Control S to save. Control V to paste the name. Now let's put it in here, and in here, and in here, and save. And hopefully it shows up in there. There it goes. Perfect. Okay. All right. Purpose. So Lab 7, Chapter 8 is all about arrays. So we're talking about static arrays and dynamic arrays. All right. So that's what we're trying to do here. So purpose is create a Caesar cipher using strings as static arrays of chars. Okay. Create a Caesar cipher using strings as static arrays of chars. Now the character, I guess it's a primitive type, is not on the AP Java subset, so you really don't need to know how to do this stuff with chars. Make this a little smaller. Font size smaller. A little bit smaller. Maybe if I move this over. Move this over a little bit. All right. Wow. How big did this get? I made this big for some reason at some point. All right, well, of cars, okay? There you go. And let's see. Required files. Yeah, that's not going to work. Like I said, it's going to be this file, which is your main class. And I don't have to capitalize that, do I? And then it's going to be this file. Right, which is the derived class. Good. All right, translator. Translator phase. Here you go. It's not going to fit too good here. Line this up a little bit better. Okay, it's going to be Java C, the tester. Okay, interpreter phase. It's going to Java the testing class, but we're going to put in here the text to encode. How about that? Now we're using the Rot13 because, well, it is Rot13. You take every letter. You're only going to encrypt the letters, uppercase and lowercase letters. Spaces and punctuation, you just leave alone. The way you just copy it, you don't change it in the encrypted code. All you're doing is you're moving 13 letters ahead in the alphabet. But if you run out of letters, like if you go past Z, then you rotate back to A. That's why it's called Rot, rotate 13. So we're moving 13 ahead and we rotate to the beginning. So we have to keep track of lowercase letters A through Z and uppercase letters A through Z. But that's it. Anything else just gets copied directly. Basically ignored. Okay. So, whoops, that's my mouse. Okay. So there's that. So I don't think I'm going to be importing scanner or anything weird. Okay, so here's my main class. Public class Rot13 tester. Public static void main string array args. So we're using that for input, right? arg0 will be our inputted text to encode. So notice that you already have some familiarity with arrays. This is a static string array. That's different from the data structure we're going to use in the private instance field of Rot13a. Rot13a is just going to be a bunch of strings. The instance fields, text in is a string, text out is a string. It could be a word, it could be a sentence, it could be a book, whatever it is. This is different. This is an array, right? An array with strings in it. But you get the idea, you know what arg0 is, and args1 is, and args2 is, right? arg0 is the first element, it's a string. arg1 is the second element, it's a string. args2 is the third element, it's a string. Okay, that's different. Right now what I'm going to do is going to decompose or parse a string into its component characters. So a string location the sub-0 of a string is a character. So say I have a string Baldwin. Sub-0 is the capital B. Sub-1 is the A. Sub-2 is the L, and so forth. Okay, so we're going to break down the string, parse the string into its constituent characters. Then we're going to encrypt those characters and then zip them back up into an output string. Okay, that's basically the idea. So all I'm going to do here is create a Rot13a object. Call it foo. Equals new Rot13, and we're going to take string straight off the command line, args0. Okay. All right, then all we got to do is print out the text in and then print out the text out. Okay, so let's do this. System.out.println. So this tester is going to be very similar for all three versions of Rot13a, Rot13a, or B or C, okay? So print, let's do a print. What is the text inputted? Okay. And then we'll just print it out. So system.out.println, this will be a print line, then the line, and we're just going to do foo.getTextIn. There you go. Oops. All right, let's get this much working, then we'll figure out text out. Save it. All right, so let's make the class a new file. Alrighty. So this is Rot13a.java. A single line comment will do. Your name, the date. Alright, so public class Rot13. Well, you know what? I should save this. So let me copy this. Control S, Control V. Let's make sure we're in here, and then we're in here, and we're in here, and boom. And it shows up down there, right? Yep, there it is. Okay, so public class Rot13a. Right? Yes. Okay. So let's start with the constructor like we usually do. Public or not, public. Void or not, neither. It's Rot13a. Now it's taking in a string argument as input. How about string S? All right. And so text in is just S. Then we'll figure out text out. All right, so let's get the tester working so far. We want the constructor. Now I want the constructor also to build text out. Okay, we'll get to that. But right now, let's just get the constructor and the text in get text in method accessor working. So public or not, public. Void or not, not. It returns a string, and all it's doing is returning text in, right? So return text in. Don't forget that's a private instance field, so we better encapsulate that. Private string text in. All right, so this much should be very straightforward. Let's test it. All right, so let's Java C Rot13 tester.java. What did I do? Did I spell it weird? Must have spelled it weird. OMG, what did I call it? Get text. Whoopsie. And of course, you caught that watching me type that, and you didn't say anything. Okay. Good. And then this Java is Java it. Now remember the command line. We have command line input, right? Yeah. So that's not going to work. So how about, I don't know, bold one. And there it is. Perfect. That's it. All right. Now let's encrypt. So what I want to do is add to the tester. I'm going to say, okay, that's for text in. Let's print out text out. Let's let text in and text out be very simple accessors. Let's make the constructor do all the work. So let's just do text out here and text out here. Camel case, camel case. Okay. I will save that, and that's the tester, and it's the same tester pretty much except for the A, B, and C part, right? For all three versions. So I want the interface of the class to be the same. The user doesn't need to know the inner workings of our class, right? Okay, so this is what I'm going to do. This is what we decided to do. We found it easiest to do this. Let's go and let's I hate to say this, it's almost like a two-string, but all right, let's traverse the string as if it were an array. So for int I starts at 0. goes to I is less than string.length, the length method in the string class. Okay, and I++. So we're going to look at every element in the string, every character in the string. So text out plus equals encrypt. This is how we did it. We created a private helper function, encrypt, okay, that does the Caesar cipher. So encrypt s.carat I. So what that does is it takes the ith character off the string, sends it to encrypt, it encrypts it, sends it back, and then it gets concatenated to text out, which means we better initialize text out, say is the empty string. Yeah, space this out a little bit. Okay. That's it. Now the work that we have to do is now an encrypt, but we also need the accessor get text out. Guess what? It's almost exactly the same as get text in then. That's another accessor when you do your Java doc. Whoopsie. So we call this get text out and text out. Okay, so those are the two accessors we need. There's the constructor. All right, now here's the private helper method. I'm not using this in the main class or the client class, so I'm going to say public or not private, void or not char, because what I'm going to do is I'm going to take in chars, I'm going to spit out chars, and then I'm going to concatenate them one at a time on top of text out, which is right now empty. Then concatenate one character, there's a one character string, then concatenate another character, there's a two character string, and so forth. So encrypt, and we're inputting a char from the constructor. All right, then basically what we said was, all right, this is what we said. First we did, this is what we did. We said, what if it's an uppercase? Yeah, we got to keep track of if it's an uppercase or lowercase. So if character, the character class, like the integer class and the double class, right? The character dot is upper. Again, this is not something you need to know for the AP exam, but it's sort of nice. Uppercase. If it is an uppercase character, okay, then we'll encode it as an uppercase letter, right? Else if it's lowercase. So notice it's not just an else, because if is uppercase returns true, not only is it an uppercase, it's a character. So what this does is it ignores spacing and punctuation, stuff like that. It's only going to talk about the uppercase letters A through Z and the lowercase letters, and the lowercase letters A through Z. Okay. There you go. All right, so if it is uppercase, what did we do? We returned a new character, right? So this is what we did. We took character minus character A, okay? So what does that do? Well, remember, a character is really an int, which represents the ASCII code. So if I take the int, is capital A 65 in base 10 ASCII code, or it's 97? I always mix that up. I think it's 97 for uppercase A and 65 for lowercase a. Okay, whichever it is. If we subtract that from the current character, if it's A, you got 0. If it's B, you got 1. If it's C, you got 2. So it's setting everything down to 0, right? Then we take that quantity, minus. Then we take that quantity, right? So we're taking a character minus a character. It's really ASCII codes. Then we added 13 to that. But then we took that quantity and made sure that it wasn't too big, if it wasn't beyond capital Z. So what did we do? We did a mod 26, because it's 26 letters. Right? So if it's 26, 0 through 25, since I'm subtracting the capital A, right? 0 through 25 is the alphabet, A through Z, capital A through Z, right? So if we got 26, mod 26 will give you 0, that gets back to capital A, right? So it'll rotate back to the beginning. So that way I'm isolating A through Z, capital A through Z in the ASCII code. I'm not worrying about anything else. All right, then what we did was, all right, after that, let's shift it back to where capital A started. And then we're going to take all of that, because these are really ASCII codes that are ints. We're going to take all of that and cast that all as a char. Alrighty? And then this return statement is basically the same thing. Oops, don't forget a semicolon. Except we're dealing with lowercase. So let's subtract the lowercase a. So it's like a horizontal shift to, you know, a to the left and the a to the right back to where you started. Okay, so now this is the lowercase, so I better take, if lowercase ASCII code, lowercase a's ASCII code is 65, it's subtracting 65. If the uppercase ASCII code is 97, subtracting 97. Is that what it is? I think I got it back. I always get it backwards. It's probably the other way around. Look it up. Okay, I think that's it. And except for your Java doc. You can do a Java doc on your own. It's a constructor, it's an accessor, it's a... What the hell is it? It's not a mutator because it's not doing anything to text in or text out, although text in, text out is affected here. It has input like a mutator might. I mean, it has output like an accessor might. This is almost like a hybrid method. I don't know what the heck this is. It's a private helper method, okay? That's what it is. All right, save it. Let's see if this works. So, clear. What do we got so far? We've got Rot13a is .java is 694 bytes or keystrokes. Rot13 tester.java is 682. All right, we're going to change that because we got to Java C everything. Oh, what'd I do? What'd I do? What'd I do? Oh, what'd I do? Oh, I forgot to make a private for a private instance field for text out. We said we needed it, right? Jeez, do what I say. Do as I say, not as I do. Okay, there you go. All right, save it. Control S. Okay, clear all this mess. Java C it. Okay, now what? Oopsie. Oh yeah. Well, notice if this is true, it returns stuff. If this is true, it returns stuff. What if they're both false? You're not returning anything, and so you're breaking your bargain with your your post condition, right? So that's part of your post condition. So otherwise, return ch. In other words, if we didn't return anything, it's because we're not encrypting it. It's a space or a punctuation. Just return it as is. Don't change it. All right, good. Here's my bold one. There it is. All right, so there's the output. Now, what's nice about Rot13, you can do Rot anything. In fact, very early email used to have Rot13 as an option. Wow, it's really hard to decrypt. It turns out Rot13 is its own decryptor. So the encrypt method and the decrypt method are the same. So I'm not going to make a decrypt method. If it was Rot something else, Rot N, or Rot 12, or whatever, Rot N, you could change it, whatever you want. So N is 3 or something. You'd have to write it your own separate decryptor because it's not the same. But the point is this. If this works correctly, if this is my input, the output should be bold one. And it works. Perfect. That's nice. Or you could do silly stuff like, okay, you're a mean one, Mr. Grinch, and so forth, right? Whoopsie, what'd I do? Doesn't like that. Okay. Wait, hang on. Oh, okay. Since I want arg0 to be all of this, so let's put it in quotes. There you go. All right, so there's your encrypted message. Lieber Inzarbar Zibir Tarparu. Okay. The point is, if I encrypt this, it should go back to what it started with. Yeah, and the command line, if you put it in quotes, is one big long string, so we're fine. So, quote, we encrypted message, unquote, and you're back to normal. Yep, nice. Okay. How about man, plan, Panama. That's a palindrome. I don't know why I'm using a palindrome here, but okay. So azuni in sinu, isina. I can't even say it. Okay, so now will it decrypt properly? You have fun with this. Take all the lyrics for the Grinch, copy and paste them. What happened here? What happened here? Something weird happened. Why is it stuck there? What is it doing? Alright, stop it. Java, Rot13 tester. Okay, how about the rain in Spain falls. Notice uppercase stays uppercase, lowercase stays lowercase, but it gets encrypted. Commas and spaces get ignored, apostrophes, all that kind of stuff. The rain in Spain falls mainly on the plain. Alright, so there's your encrypted message. Let's see if it decrypts correctly. Java, Rot13 tester, quote, that, quote. Yep. Oh, what did I do? Did I input it weird? False. I did something weird. Alright, but, well, it decrypted correctly, right? That's it. That's it. Okay. Alright, YouTube, I think we got it. So, there's the tester. Very simple. Alright, input from the command line, and then regurgitate it and encrypt it. And then here is how we did it, where the private instance fields are both strings. And we're parsing the strings into a bunch of chars and encrypting the chars and putting them back in. So there's the loop that does the work. So using loops with arrays. There's your accessors, and there's your encryption method. And we're done. Okay, bye-bye, YouTube. Have a nice day. Hope that was helpful. Next, C7X1b will be refactoring this to use static int arrays for your private instance fields instead of string objects. Okay? All right, bye-bye.